let's take a look at some of these transformations. Here, the +2 is on the inside. That tells me this has gone left 2. This -1 is on the outside, which means it affects the y values. And since it's negative, that means we go down 1. Okay, so let's graph it. Since the parent function here is absolute value, the table that we're going to use is -2, -1, 0, 1, and 2. And the y values are 2, 1, 0, 1, 2. This value in the middle here is our vertex. Okay, so this is going to create a new table, a transformed table. The left 2 means that we're going to subtract 2 from the x values. Remember, x is inside is opposite, and since this is plus, that means we're going to do the opposite, which is subtract. This -1 on the outside, well, that tells me we're going to subtract 1 from the y values. Okay, so we'll just take all of the x values and subtract 2, and we'll end up with -4, -3, -2, -1, and 0. Then we'll take all of the y values and subtract 1. So 1, 0, -1, 0, 1. So when we plot these points, -4, 1, -3, 0, -2, -1. And again, this number here in the middle is our vertex, and the absolute value is symmetric about that point. So these other points on the right, -1, 0, and 0, 1, should be the same. So our graph is going to look like that. Again, we have absolute value. So let's first list the transformations. This negative on the outside corresponds to a reflection over the y-axis, the x-axis. There's nothing on the inside, so there's no left or right. This -4 is on the outside. That means we've gone down 4. Okay, so the parent table again for the absolute value is -2, -1, 0, 1, 2, 2, 1, 0, 1, 2. And we're going to transform it. This reflection over the x-axis, that means we are going to multiply the y values by -1. The -4 over here also impacts the y values. So I'm going to subtract 4 from the y values. Okay, so nothing happens to the x's. So all of the x's should remain the same. Now I'll follow the order of operations. I'll multiply, then subtract. So 2 times -1 is -2. -4 is -6. 1 times -1 is -1. -4 is -5. And we'll just continue on down. And notice, once you get to the vertex here, these numbers are going to be the same as these numbers. So, because the absolute value is symmetric, so these are going to be the same as these. Okay, so -2, -6. Oops. -1, -5, 0, -4, and so on. So we see that it's now going down. So it's been reflected over the y-axis. I don't want that erase. There we go. And it's been shifted down. Okay, here's another absolute value. So let's start out by listing the transformations. This negative on the outside means it's been reflected over the x-axis. This 3, that corresponds to a vertical stretch of 3. This -2 on the inside, that impacts the x values, and x goes left and right. And inside is opposite. So this means it's gone right 2. And lastly, this -4 on the outside, that impacts the y values. So that tells me that it's gone down 4. Okay. So now let's take a look at this graph. Okay, so the reflection over the x-axis, that means we're going to multiply the y values by -1. This vertical stretch of 3, that means we're also going to multiply the y values by 3. So instead of multiplying by -1, let's just multiply by -3. That takes care of both simultaneously. This right 2 means that we are going to add 2 to all of the x values. Remember, inside is opposite. And since this is a -2, that means we're going to have a +2 here. Now this down 4, that impacts the y values. So we're going to subtract 4. Okay, so let's go ahead and do all that. So -2 plus 2 is 0. -1 plus 2 is 1. 0 plus 2 is 2. And since it's symmetric, these are going to be the same. Or no, the symmetry is for the y's. These are going to be 3, 3, and 4. These are going to count up. Okay, so now let's do the y's. So 2 times -3 is -6, -4 is -10. 1 times -3 is -3. -4 is -7. 0 times -3 is 0. -4 is -4. And since it's symmetric, these values are going to be the same as these. Now, I think my graph might be a little too small to fit all of these on here, but that's okay, we'll do our best. So 0, -10, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's just put it right down here. 1, -7 is going to be here. 2, -4, it's going to be 3, 4, right here. 3, -7 is going to be here. There we go. Notice that this is skinnier. It's narrower than the other ones. That's because of the stretch. You can also think of it as being longer this way. Okay, so now let's look at some quadratics. In a quadratic, the same process applies. We're just using a different table. I only see one transformation here, the -2, and it is outside the square. So that means we've gone down 2. Now the table that we're going to use for a quadratic is -2, -1, 0, 1, 2. These are the same values the same x values we used for the absolute value. But we're squaring these now because we have a square. So negative 2 squared is 4. Negative 1 squared is 1. And so on. Now let's make our transformation. Since we are going down 2, that means we are subtracting 2 from the y values. But the x's don't change. So since the x's don't change, we can just copy these down. And now let's subtract 2 from all the y values. So 4 minus 2 is 2. 1 minus 2 is negative 1. 0 minus 2 is negative 2. These are going to be the same as these. Okay? So now let's go ahead and plot these points. Negative 2, 2. Negative 1, negative 1. 0, negative 2. And these are going to be the same. Okay, so we have our U shape. And let's just pretend it went through that point. Just make it a bigger point. There we go. All right, let's do another one. Okay, this minus 2 is on the inside of the square. That means we've gone left 2. This plus 1 is on the outside. That means we've gone up 1. Like before, the parent here is the square. So the table we're going to use is negative 1, or negative 2, negative 1, 0, 1, 2. And now we're just going to square all these. So let's make our transformation. This left 2 is going to impact the x's. And since this is plus, we're going to do the opposite. So we'll subtract 2 from the x's. Now it's gone up 1, which means we're going to add 1 to all of the y's. So if I add 2 to all of these x's, negative 2 minus, I'm sorry, if I subtract 2, negative 2 minus 2 is minus 4. Negative 1 minus 2 is negative 3. Negative 2, negative 1, and 0. Now let's add 1 to all of these. 5, 1, oops, 2, 1, 2, 5. So now all we have to do is plot these points. And again, this point right here in the middle, that's going to be the vertex. So that should wind up in the middle. Negative 4, negative 5. Oops. Negative 4, positive 5. Negative 3, positive 2. Negative 2, 1. And these are going to be a mirror image of these. Okay. So we can see our parent function, which normally has a vertex here at 0, has gone left 2 and up 1. All right, let's do one more. Again, we have a quadratic. The parent here is a quadratic. This negative on the outside is a reflection. So this has been reflected over the x-axis. This minus 2 is on the inside, which is the opposite. So this is right 2. So since this is a quadratic, the table we're going to use is negative 2, negative 1, 0, 1, 2. And we'll square all of these to get 4, 1, 0, 1, 4. Now let's make our transformation. This minus on the outside, that's a reflection over the x-axis. That changes the y values. So we're going to multiply the y values by negative 1. the right 2, and this is on the inside, so it's opposite, which means we are going to add 2 to all of the y values. So I'm going to add 2 to all of these. Negative 2 plus 2 is 0. Negative 1 plus 2 is 1. 0 plus 2 is 2, etc. Now I'm going to multiply all of the y values by negative 1. So negative 4 times negative 1 is negative 4. Negative 1 times negative 1 is negative 1, etc. Now we'll simply plot the points. 0, negative 4. 1, 2, 3, 4. 1, negative 1. 2, 0. And the other points are going to be a mirror image of these points. So here we have our quadratic. And you'll notice that this quadratic went right 2. So it started here and it simply went right 2. And then it was also reflected over the x-axis. That's why it's upside down. So I hope these examples helped, and thank you for watching.